Welcome to Section 7, Authorization, Deployment and Managing Secret Keys. In the last few sections we've been focused on authentication, which assigns a user to the current session. In this section we're going to start by focusing on authorization, which assigns permissions to that current user. We'll then look at deployment and continuous integration, and finally we'll look at managing secret keys. We'll look at authorization in general. We'll look at the typical schema for roles and permissions, and then we'll cover some common techniques for sharing identity between a web application and an API. Most business apps take some variation on this schema for controlling authorization. Users are given roles, and roles each have a set of permissions. And there's a many-to-many relationship both between users and roles and permissions. That is, a user can have multiple roles and a role can have multiple permissions, but obviously there are multiple users who have the same roles and the same permission can appear in multiple roles. And this tends to be flexible enough for most business applications. In an application like GitHub, you have a role on a repository and a role on an organization. Permissions then flow from a combination of those two roles. On Facebook, you can have a role on a page that gives you permission to perform certain actions on behalf of that page. You might also have a role in a group that grants you permission to manage that group. But as a user, you don't typically have a role to control, which posts you can see. Instead, your right to see some content comes from being friends with a given user, and them having set that content as shared with their friends. The general principle here is that no user should be able to give someone else permission to do something that they can't do themselves. If a user could grant someone else permissions that they don't have themselves, they could escalate their own privilege to be able to perform those actions as well. It's fine to have users that can do certain things but can't give other people permission to do those things. And this is commonly what we want in a corporate environment, where you might have a few people who are centrally responsible for allocating roles and permissions to other people. But in consumer applications, you're much more likely to build it so that individual people can give other people rights to do most of the actions that they themselves can do. Another key principle in authorization, and for that matter security in general, is that you should always try to default to the most secure option. This implies, in terms of user experience, where everyone is allocated the minimum set of permissions to start with, and then has to be manually granted additional permissions as needed. It also applies in terms of software, in that it's better to try and make things fail safe, rather than fail into an open state. This means you should try and write your code so that if you make a mistake, people will be granted too few permissions, not too many permissions. So if you were calling a function has permission to do something that should return true or false to indicate whether a user has permission to do a thing, you could simply say that if the result is not false, they can do the thing. But it's far safer to explicitly check that true is returned and fail in all other cases. The obvious reason for this is it's safer to make that assumption, but the other reason is that your users are more likely to tell you straight away if they don't have permission to do something that they need or expect to be able to do. They're unlikely to tell you or even notice that they have permission to do something that they should be blocked from doing. So you simply might not find out about those mistakes. So I know we've been talking about authentication for many sections now, but I wanted to quickly look at how we get that authentication from our application to our API. If our app and our API are running as part of the same monolithic application, we can simply use the same cookie value that we already have to do authentication in APIs. Anytime we're using cookies, we have to be very careful and conscious of cross-site request forgery issues that we covered in section 2. And the other approaches I'm going to talk about help to mitigate that risk as well. If our API is running on a different server or domain to our main application, we will need to use some form of token. We can use a straightforward random string generated by hex encoding a call to crypto.randomBytes. This token should be stored in the database and set to expire after some relatively short window of time, such as a few hours or at most a few days. The client application should then refetch tokens from the backend periodically. These tokens should be treated a lot like passwords, but you can mitigate many of the problems with passwords by making them expire and making them extremely long. If you make the token consist of a separate ID and secret portion, you can also then rate limit attempts to guess the secret portion, making them much more secure. An alternative to a straightforward random token is a JSON web token. These are blobs of JSON data that have been signed using a secret key. You can either use a shared secret, that is just a random string of data shared between the app and the API, or you can use public-private key pairs, which has the advantage that the API server does not need to hold the secrets required to generate the API tokens. The biggest downside of JSON web tokens versus random tokens is that because you don't store them server-side, they can't easily be invalidated until they expire naturally. This is probably okay as long as they have fairly short expiration durations, but it's something to consider. Because they're just blobs of JSON, you can actually encode all of the roles and permissions directly in the token. You should be wary of the fact that the token must be passed with every single request. So if it grows too big, it will negatively affect your application's performance. Regardless of what form of token you use, you should always pass it in the authorization header. This way, most automated server-side logging solutions should exclude that token from the logs. If you pass it as a different header, or if you pass it as something like a query string parameter in the URL, it'll be included in logs, which are generally not treated as cautiously or sensitively as passwords in your application. The convention here is to have the value of the header start with the string bearer, followed by a space, and then the token.